In this video, we begin our discussion of Unit 11, which is centered on Introduction to Correlation and Simple Linear Regression Analysis. In particular, we'll be interested in situations where if we're given two numerical variables, say number of miles driven weekly and the amount spent on gas measured in dollars, you particularly note that these are two numerical variables. What do you think? Do you think there is any association between the number of miles driven weekly by workers at a particular factory and the amounts that they spend on gas? This is the kind of questions we're going to answer using statistical methods. So to get started, let us consider an example of where we start our analysis of two numerical variables. In this example, we ask a leading question. How exactly does Zillow figure the worth of a house? Sometimes the first thing often mentioned in describing a house for sale is the size of that house or the size of the living area. Let's start with just one variable like the size of the living area that house prices can depend on. So we ask the research question. How well can living area be used to predict home price? In other words, does home price, does it depend, does the home price, does it depend on the living area? If that is the case, then we might be able to explore how they are connected. The first step in analyzing the relationship or absence thereof between two numerical variables, say the home prices and the size of the living area measured in square feet, is to plot a scatter plot or a scatter diagram. In this case, each dot here represents a home. And for that home, we've collected data on the living area and the price of that home. So, and based on the data collected and illustrated in this picture or in this scatter plot, we can establish a trend line. This trend line tells us something that as far as what the home prices are concerned, they seem to be connected to the size of the living area. So it means that the home price would be a dependent or response variable that responds to the independent variable, which is the size of the living area. And if we are to comment on the relationship between these two variables based on the trend line we can see in this plot, this is what we can say. There are four key areas where we will need to comment. 1, direction. 2, form. 3, strength. 4, outliers. As far as the direction is concerned, this line suggests a positive slope. That is, in the same way your right hand will slope down if you held it up. And for the form, I can see a linear form. That is the form of a line. There are other forms too that might arise sometimes. You can have quadratic, you can have exponential, we can have logistic, and so on. But for this introductory part of the class, we're looking at linear models. Okay, then next, what about the strength? That is usually measured by how clustered together, how tightly clustered the points are. From what I can see here, most of the points are tightly clustered together, but there are some stragglers here. So I would say that subjectively speaking, in this context, that there is a moderately strong relationship, strong association between the home prices and the size of the living area. Then, do we have any outliers? Apparently, this guy might be a potential outlier. So I'm also going to comment that there are some potential outliers, and that might need some more investigation to check out why those are outliers. So the first step in analyzing the relationship between two numerical variables is to plot a scatter plot and then comment on that scatter plot in terms of the direction, form of the relationship, the strength, and whether they are outliers or not. Let's consider another example. The Texas Transportation Institute, founded in 1950, studies and develops solutions to challenges faced by all forms of transportation. Although the goal is to solve the transportation problems of 2025, the TTI started collecting data on the relationship between freeway speed and the cost to society of freeway congestion per person. So, which of the highlighted variables should be assigned to the role of response variable and explanatory variable? That is, which depends on the other. I would say that what it will cost in the pocket of an individual if they're stuck in traffic would depend on the speed of the what? Freeway. So it follows that our response variable, represented as Y, would be congestion cost per person, and that depends on the explanatory or independent or predictor variable, which is the peak period freeway speed. And as far as the data we have collected is represented in a scatter plot, I can see a trend line, but this time it is sloping downward in the way my left hand will slope downward if I were to hold it up. So, based on that, the direction this time is negative. So we have a negative direction for the linear form of the relationship between these two variables, forms a line. And what can we say about the strength? Subjectively speaking, I can round up most of these points. They seem to be tightly clustered together, so I'll say this is a reasonably strong association, between the two variables, and that makes intuitive sense. And do we have outliers, any stragglers in the points? I would say that there are no extreme outliers. There are no extreme outliers. So as it stands, whenever we want to start exploring the relationship between two numerical variables, we must draw a scatter plot and identify the direction, the form, strength of the relationship, and if there are any outliers observed in the data collected. And then we proceed to yet another example. For each of the 6 scatter plots shown below, we're to identify the strengths of the relationship, weak, moderate, or strong. Remember, this is indicated by how tightly clustered the points are. I would say that this band right here, I would say this is moderate. And I would say moderate because in comparison with this guy, this seems to be more what? Clustered together, more tightly clustered together. So I would say strong relationship. In this band here, I would say also strong. Whereas in this band here, they're more scattered around. I would say moderate. And lastly, in the last two, I can't see any clearly discernible pattern. So I would say weak. weak, or not even existent. This is also weak. So we continue the question, and we want to see whether fitting a linear model will be reasonable. What do you think? Would a line be a good fit for the first one? Well, I can see that most of the points, so this would be appropriate for a linear model. This guy, non-linear. This is curved. This is a curved or non-linear model. This is also non-linear model. This will follow a line, so definitely a linear model would be a good representation. And those that are weak, we have what? No association, more likely. In other words, we don't need a model to represent an association that does not exist. The same goes with this. In particular, for those who have linear models, you might recall y equals mx plus b, where m will be the slope of that line and b will be the value of y where the line crosses the y axis, called the y-intercept. This is coming right up. So our linear model will have the form y equals mx plus b. And we're going to see how to get the parameters or the regression parameters, namely the slope and the y-intercept. All right, let's take one more example for you. So you can pause the video at this point and try to look at this. Which of the scatter plots show little to no association? Is it 1, 2, 3, or 4? What do you think? I would say 4. What about a negative association? That would have to be linear, and it will have to slope downwards like my left hand held up. So I would say 3. And what about a linear association? Well, I can see a linear association in 2 and 3. So I'm going to say 2 and 3. Then what about a non-linear association? What do you think? I see a curved one here. So I would say 1. That means there's an association. It is just not linear. The last one says, what about a very strong linear association? That means it is linear and the points are tightly clustered together. So that would be 3. All right. In the next video, we'll start talking about how to measure the correlation coefficient, how to compute that. And that is a very good measure of how strong these points are clustered together. And by extension, the relationship between your dependent or response variable and your independent or predictor or explanatory variable.